Buenos días, buenas tardes, buenas noches, damas y caballeros. El día de hoy nos encontramos aquí en su programa No te comas eso, en el canal Keto Sucio, con el día de hoy un invitado muy especial. El día de hoy vamos a ver un video completamente en inglés. Y esto es porque decidí invitar a un científico. ¿Por qué decidí hacer esto? Pues últimamente muchas personas en el medio están diciendo bastantes idioteces sobre la ciencia. Muchas de ellas las hacen diciendo que ellos mismos saben qué es la ciencia y pues eso no es cierto. Así es que decidí invitar a un verdadero científico a que nos explique cómo funciona el metabolismo. Nos va a tener que explicar en inglés. Le voy a hacer una serie de preguntas y yo les voy a dejar todo el video con subtítulos. Estamos listos y comenzamos. How are you, Bart? Thank you for being here. Él es Bart Kay, profesor emérito de la universidad. ¿Me recuerda, por favor? Can you remember me, please? The university?
Yes, I worked at probably about 10 different universities throughout my academic career on 4 different continents, none of whom I'll be naming here today.
Okay,
yeah,
good.
I've been around is what I'm saying.
Okay, okay. So I have some questions that I have prepared for you. First of all, that it's important for me. It's who is Bart Kay and why should we believe him?
Right. Yep. So who am I? I'm a former academic who is now retired completely from academia. I have no intention of ever returning to academia. I was an academic for just over 2 decades, during which time I specialized in the physiology of rest and exercise, sports science, if you like. Then I moved to human nutrition, spent a few years there, and then I abandoned that field pretty much and went to cardiovascular pathophysiology. So heart disease, what causes that, what doesn't cause that kind of stuff. All of that is overarched by a pretty good understanding of both statistics and research methodology. Published a number of peer-reviewed articles during my career, undertook a number of large, financially large consultancies, and taught students, as I say, on 4 different continents. So, yeah, that's pretty much where I'm coming from.
Okay, so the word professor doesn't mean that actually you just give classes. It doesn't mean that you're a teacher. Am I right?
Professor is a rank, much like general is a rank in the military. In academia, your job description is sometimes referred to by your rank, lecturer, senior lecturer, professor, whatever, but that's not actually a job description. That is a rank. And much like when someone is in the military and you say, what do you do for a living? They might say, I'm a captain in the military. So I would say I used to be a professor in academia. Now I'm what's called an emeritus or emeritus professor, which means retired, basically.
Professor emérito.
Yes,
I'm sorry,
that's it.
translating.
Yeah, absolutely. Yeah, absolutely. Professors may or may not teach. They may or may not be involved in research. There are a number of ways to gain a professorship rank, if you like. There are several common examples. I'll give you a couple just for fun. Someone who is involved in the research and publishes a huge body of literature in a contiguous area of science will get promoted up through the ranks to become a professor. That's one way. Another way that somebody might make professor is by bringing in a huge research grant from somewhere. There's another way where someone can be a professor who is a clinician who is employed in academia to teach clinical practice. So that person may not teach theory or do research. And there are a bunch of other ways as well, but they're the 3 most common ones. And my particular background, I keep very much to myself these days. Reason being that a lot of what I say publicly on the internet is not popular. And so I don't want people to be able to trace me down and find me. It's called doxing, basically. And so I keep that pretty close to my chest. So there you go. There's an explanation on that one.
Okay, so I I'm going to talk a little bit in Spanish. Solo para clarificar, él es profesor emérito, ha dado clases en muchas universidades en 4 continentes del mundo, pero no es profesor por dar clases, sino lo que me dice es que el rango de profesor es un rango como en especie en la militar, en la milicia, y pues este rango se lo ganó él haciendo investigación. That's what I'm understanding. You gain this rank by making research. Así es que y ahora yo le voy a preguntar cómo rayos llega un científico a la dieta carnívora. How do a scientist gets into a carnivore diet? That's weird.
Well, it depends on the ability of the scientist concerned to actually engage with science itself and understand what the level of science is in human nutrition. As someone who's worked in that field specifically for a part of my career at least, I can promise you that the level of science in human nutrition is basically absent. There is none. So the reasons that I decided for myself to go carnivore were based in anything but the so-called human nutrition science.
Okay, so what we know about the human nutrition science what they are selling us as science, then is not science. What
Correct.
It is, investigation, research, what it is? How can we call it?
Well, it's all about discipline. It's all about how one describes the level of the work that they have done. It's perfectly okay to say, we did some investigation into the possible relationships between X and Y under the guise that we attempted as best as is possible with human beings to control and observe properly. However, given that ethics committees are absolutely dead set against locking people up in laboratories for years and years on end and experimenting on them, we can't do, because that's what science is. Science is controlled, disciplined. It's absolutely what we do is we determine cause and effect by eliminating every other possibility. You cannot do that with human beings. You have to get as close as you can get, in which case what you should do is say, well, we're getting as close as we can here. However, we are unable to make that step and to say this causes that. That's where the discipline falls over, because people whose careers are bound up in the so-called nutrition science always want to self-aggrandize and make what they're doing more important than it really is. We have absolutely proved this, that, and the other thing, they will tell you. No, what you've done is you've been prepared to accept ill-disciplined pseudoscience because you can't do actual science, and still in an ill-disciplined fashion describe that work as cause and effect work when it is not. That's my problem with it.
So what I'm understanding here is that they are selling us as science something that is not science, is pseudoscience, and it's not fully done. It's
Right.
half work. Something. Yeah, okay.
Yeah, I describe it as a theology, as a belief structure, and that's what it is. It's also a bought and paid for propaganda establishment, absolutely, without any question at all. For example, you take a look at the people who sit on the board that set the dietary guidelines, for example, for Americans. Every single one of those individuals has multiple conflicts of interest with industry, millions and millions of dollars worth. Not one of those people is clean in terms of their ability to advise people on what they should eat based on the science or even on best practice, because they are all bought and paid for, every man jack of them, every one of them. For example, and the same goes on in all other countries. It's not just America; it's everywhere.
Yeah, I'm just gonna rephrase it here because I want just to make it clear for the audience.
Sure.
So, a scientist is telling us that what they are selling us as science is corrupted.
Yes. Absolutely.
Thank you so
Absolutely,
much.
without question. Totally corrupt, the whole lot. Yep.
Thank you so much. I wanted to clarify that because I think it's important.
Mm.
So I want to ask you, this is something that people ask me really frequently, and they tell me, carnivore is an extreme. I don't want to go to extremes. Why do you go to extreme? But I don't feel it as an
Right.
extreme. Do
Yeah.
you?
No, it's not extreme at all. No, I tell you what is extreme. Extreme is living a life that is shorter than it ought to be and spending much of that shorter than it should be lifespan chronically ill because you believe these criminals that have been bought and paid for to tell you lies. And you eat a standard Western or standard American diet and you become obese, you get diabetes, you end up with cancer and heart disease, dementia, and all of these kind of things that are absolutely, in my understanding of physiology, which is significant, all of these things are explainable from that diet because it is totally inappropriate for a human being to eat the way we're told we ought to. Totally inappropriate. That's what's extreme. There's nothing extreme about an animal, any animal, and human beings are an animal, whether you like it or not, we are. Every single animal has evolved in a niche as a specialist. What does a cow eat? Grass. What do lions eat? Elk, etc. Those kind of things that they get on the plains, those things that eat the grass. They are specialists, as are we as a human being. And it turns out that if you actually forget everything in this ring-fenced area of ideology, the human nutrition science, ignore all of that, black it out from your vision, look at the actual hard sciences that are being done outside of that ring fence. So I'm talking human anthropological studies, looking at the remains of ancient human bones, for example, looking at fire pits put down by ancient human beings up to 1 million years old, some of these things, looking at the tools and things that we had, etc., 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 looking at things like stable isotope testing from the collagen taken from the long bones of ancient human beings, telling us exactly what that human did eat, for example, when it was alive. Other areas include comparative anatomy and physiology, looking at the human system and comparing that to other animals, who are all specialists, to see which one we most closely resemble. And I'll give you a clue. It's not that we're not carnivores because we don't have sharp, pointy teeth like this. That's crazy. Tell you why. I've never seen a painting of hunting men on a wall of a cave where they are diving headlong at the mammoths with their mouths open. Not one of the pictures shows the men doing that. Why not? Because they weren't doing that. They were using sharp, pointy sticks that they fashioned using opposable thumbs according to a plan put forward by their brains, which were more intelligent than the average animal. And they worked together with strategy because they're able to communicate using the language they made up because they were so much smarter than the other animals. We don't need sharp, pointy teeth. Ergo, there's no selection pressure to have sharp, pointy teeth. But you look at the system overall, never mind the teeth, and just about every other part of our digestive system tells us very, very clearly what a human being should eat. And it's the flesh and fat of animals, almost exclusively, not plants at all, in fact, to speak of. So that's how I've come to the conclusion that the carnivore diet is probably the best one for a human being. Then we compare that to the anecdotes, the stories of this community of people who have really made ourselves known to each other through social media. And we can point to examples of people who have been eating nothing but animal flesh and fat, no plants, for in one case up to 67 years that we know about. So we know that this is sustainable long term. And what we also know from the reports of these people is that their health is vastly improved from what it was when they were eating any amount of plant material according to what they were taught. So to me, it all stacks up. That's fine. I don't need anything else. And I certainly don't need nutrition science to tell me otherwise, because it's rubbish, all of it.
So I get a lot of rage from people when I say that green juices are dangerous.
Yeah, welcome to my world. Yeah.
Am I exaggerating when I say green juices are dangerous?
No, you're not exaggerating. I wouldn't touch green juices with a barge pole. I wouldn't go anywhere near them. They are almost certainly stacked with oxalic acid oxalate, if you like. Very, very toxic to human beings. They've probably got phytates as well. They've probably got tannic acids in them as well. Some of them will contain deadly nightshades. Basically, plants are full of toxins. 98% of all plant material on this planet is completely inedible to a human. The rest is tolerable to some degree, but not good for us. It's all poisonous. Why? Because plants cannot hide from us, run away, fly away, jump into a stream, dive under a rock, or otherwise avoid being eaten. They're rooted to the spot. So they have to defend themselves another way. It's chemical warfare. So that's what goes on.
So the big question comes, are plants trying to kill us?
Well, that's probably anthropomorphizing plants a bit. And that's a big word, I know, anthropomorphizing. What it means is giving something human characteristics that isn't a human and can't possibly have those characteristics. Plants don't think, as far as we're aware. They don't have a nervous system in the way that animals do, as far as we're aware. They have a different sort of way of knowing what's what. So trying to, no, they're just defending themselves. They don't want to be eaten by us or insects or anybody else. They want to live and pass on their genes to the next generation of whatever plant they are. There's nothing evil about it. That's just nature. That's how it is. It's an arms race. Yeah.
Yeah, okay. So I ask this question specifically this way because of Anthony Chaffee,
Yeah.
specifically this way.
Yeah, I know it's his catchphrase. Yeah, I know that. Yeah.
But actually also because of this good and bad stuff that I was sure you were going to brought up is this thing that this is nothing good or bad within anything that we eat. It's not that it's good or bad because things are not good or bad. That's religion.
Yeah.
That's a religious ideology. This is not
Sure.
good or bad. It's how much damage can you receive from something?
Yeah.
How much damage are you able to handle, or are you willing to handle? And this is what I say to people when they ask me, can I eat this? Can I eat that? I don't know. Can you? I mean, are you willing to accept that? For example, I want to eat chocolate. I don't, because my menstruation becomes horrible. So am I willing to accept the taste, the flavor? Yes, of course. Am I willing to accept consequences? No, thank you. I haven't eaten chocolate in 6 years.
Awesome. Yeah. I find the same thing when I go off piste and eat stuff I shouldn't. My body reacts very, very strongly these days, more strongly than it did before I actually went carnivore. And I think that tells us something as well. It's like the body now suddenly realizes how it should be and how it should feel and to be healthy. And then you eat something that's not good for you and your body goes, let's give you a clear message. Yeah.
Yeah, it reacts immediately. Hey, and I wanted to ask you also, is calories in, calories out a good, sustainable diet? And why not?
Okay, right. Let's cover calories off because it's very important. Number one thing to understand is this. Calories are completely and utterly irrelevant to human metabolism. They have nothing to do with human metabolism whatsoever. Not a damn thing. Zero. Secondly, calories are made manifest as photons. Photons do not interact with the Higgs field, ergo have no rest mass, ergo cannot be brought to rest in any inertial frame, so you can't eat any calories ever, not one. Neither can you spend them because they can't be brought to rest. They are brought into being and they travel in space-time to another point where they cease to be. only in any inertial frame of reference is there any time or space involved in that. From the point of view of the photon itself, it exists everywhere, always, and never. Its mass is 0. It weighs not a single gram. Ergo, you cannot alter your weight by either consuming or releasing these things, even if you were able to do so, which you are not. It's against physics. It's ridiculous. We all need to re-educate ourselves and stop referring to the energy we receive from food as calories, because it's not. The energy that we run our metabolisms on is chemical energy. It's potential energy, not heat energy. Calories are a form of heat energy, specifically, explicitly. That's how they're defined. That's how they're measured. That's what they are. End of debate. What we run on is potential chemical energy. The thing that will change your mass, your weight, up or down, and or change the makeup of that mass, your body composition, is matter, mass, stuff that does interact with the Higgs field. In the case of metabolism, it's carbon skeletons with hydrogens attached to it and oxygens. So we've got carbohydrates, we've got proteins, we've got fats, and we've got alcohol. Those are the four. They're all physical matter with a weight. You take them in, they will change your weight upwards. Your body interacts those things chemically to use the energy in such a way as to produce more potential chemical energy, ATP. And then the exhaust is H2O, water, which also has mass, which you will excrete at some point, and carbon dioxide gas, which also is matter with a mass, which you breathe out immediately. Those are the things that will affect the makeup of your body and its composition, not calories. So we need to lose the word entirely. It's ridiculous. Of course, people will say, oh, yes, but it's just a form of energy, and energy is mathematically convertible from one form to another. Yes, it is, mathematically, absolutely. You can convert calories into kilojoules. You bet you can. That doesn't mean you have the physical machinery to actually do that, though. It's just a mathematical, like changing American dollars for Spanish, whatever they're called. So I don't even know what they're called, the Spanish currency. Right.
But they use euros.
Okay, euros. Good. Oh, of course, they're in the Eurozone, aren't they? There you go. Only a bank can do that. Or someone that has both forms of cash and can make the conversion and give you, the human body does not have that capacity. It only runs on one currency, that being potential chemical energy, not heat energy. So, the problem with calories in, calories out diets is, number one, you cannot count your calories in accurately. It is impossible. You cannot do it. Neither can you accurately assess, guesstimate, or measure how many calories you are so-called spending either. The errors are so massive that to make that diet work, what you have to do is undercut the amount of mass of food that you're eating by so-called 500 so-called calories a day to have a predictable result over a period of time. And you will lose weight doing that, yes, but you will also destroy your metabolism in the process. It's ridiculous. It's contraindicated. You ought not do it. The way to optimize your body composition as per your genetic ideal is to eat a diet which is appropriate for your species, that being the flesh and fat of animals and not plants. Then your body will normalize of its own accord, because that will normalize your hormones, which are the things that actually determine how your body reacts to the food that you feed it. Another thing that the calories in, calories out crowd completely ignore. They say, no, this is the whole argument. This is all you need to know. You need to count your calories in, which is impossible, and you need to count your calories out, which is also impossible. Ergo, we need you to undercut your food by such a large margin as you'll destroy your metabolism in so doing. Sure, you might lose some weight doing it, but then you'll rebound and you'll gain it all back, and you'll actually just get worse and worse and worse over your life. Don't do it. It's ridiculous. I hope I've been clear on that.
I ask this because there's a lot of people that have been asking me, you eat too much. I eat. I'm a little girl. I'm like 5.1 or something like that.
Okay.
And I used to weigh 200 pounds, 100 kilos, 100 kilos, and I lost 50 kilos.
Nice.
And I do that by eating about 10 to 14,000 calories a day. So I was really malnourished because I came from a vegetarian diet since I was a kid, and plant-based, not vegetarian, plant-based, but really driven of my health.
Yeah.
And when I started eating meat, just meat, it was like I couldn't stop.
Yeah.
And I ate a kilo and a half, sometimes 2 or 3 kilos of food, and 2 or 3 kilos of
So
meat.
that's what you actually did eat, 2 or 3 kilos of meat. You did not actually eat any calories at all. None. 0 calories is what you ate. Yeah.
Yeah.
And your body reacted to that by saying, now we have a time of plenty. Now I'm giving my body all the nutrition it needs. So now I can normalize my hormonal system, my cycle, all of that. My basal metabolic rate will normalize and optimize. Everything happens. It's all good. And the weight just falls off you, despite so-called eating so-called thousands of calories, which you didn't do, by the way. Yeah.
Yeah, I know, but it's like they say, if I ate this amount of food, then I ate 14,000 calories a day.
Yeah.
What are you talking about?
Well, look, while we're talking about calories, here's another one. Protein. Protein in your body, almost entirely, for most people, protein is used to make body structures. It's not oxidized for energy to make ATP. So to say it contains 4 kilocalories of energy per gram is ridiculous. It doesn't, because it doesn't get oxidized to speak of.
Okay, I understand that. It becomes an amino acids, and
and then you grow skin cells, and you grow hair, and you make bones and maintain them, and teeth, and basically your whole body structure is made of proteins. So where did those 4 calories go per gram of protein that you've been eating? It went into your body structures.
Yes, that's a very interesting thing that I think I have been having it over here, but I couldn't be able to grab it now until you're saying it. Yeah, you're right. It's not as all this thing is going to throw away or waste only in doing exercise, because I do 0 exercise in 6 years ago, folks. So
I'm not sitting in judgment. Me too.
This is exercise is not for everybody. This is something that I wanted to tell you, because people approach to me really often also to tell me, but we have to eat veggies, they're nourishment, they're nutritious. And I tell them, no, nutritious meat is nutritious, and it's fully known that meat is the most nutritious food. But the problem is that the research comes from paid studies, so I cannot show any science, because everything's paid.
But the point is, neither can they. Anything they flash in front of you says, look, this proves, but no, it doesn't. It's rubbish. All of it still. There's nothing in there that proves a damn thing. Promise you. As a scientist,
no, I don't.
Absolutely promise you. At the end of the day, what they have is a theology that is bought and paid for, and a really good indoctrination, brainwashing program that we get kids almost from the time they can understand language, and we tell them fruit and vegetables are good for you, fruit and vegetables are good for you, fruit and vegetables are good for you, they'll say. Everywhere you look, that's what they will say. It's false. You do not need to eat a single gram of plant material ever if you don't want to. None. There is no science that says otherwise. Absolutely everything you require as a human being nutritionally will be found in the muscle, meat, and associated fat of large ruminant animals, or even smaller ones like sheep's.
Or even non-ruminants like pork, but
Sure, pretty much, yep.
I know you eat ruminants. I eat pork maybe.
Pork's great. I love pork too. Pork's a fair bit of my diet as well. Yeah.
So this led me wondering myself and looking around, because people is very indoctrinated, as you say, but they are also fighting this war in favor of people or of things they don't understand, and this is because they understand the natural human diet, and this is something I have been wanting to ask you for years now, and it's the question that I have here is, what is the natural human diet and why? But what my actual question is, why you spell it that way? You say it in a specific way.
A species appropriate, species specific diet?
Yes.
Yeah.
Why?
Okay. Well, I say it that way because natural selection pressures, both positive and negative, are a thing. They do exist. There's no question. Whether you believe in a God or whether you don't believe in a God makes no difference. It's still a fact. Evolution, therefore, is a thing. It does not preclude the existence of a God. If you believe in that, that's fine, whoever you might be, dear listener. I don't have any problem with that. However, all species on this planet do evolve every single generation to some degree, a small amount. And over deep time, species change hugely on the basis of what is positively selected for, that which was useful in our genes, and that which is negatively selected against, that which was negative. An example of a gene that is completely wiped out in all human beings because it was negative is the gene that would allow us to make our own vitamin C. We cannot do that because that gene was a problem. It was wiped out about 4.5 million years ago. There's theories around why, but we don't have time for that today. It's just an example of how that is. Another example of a total sweep in a population of a gene is in the Inuit, who live above the Arctic Circle. They have a particular genetic patterning amongst all of them, either homozygous or heterozygous, which prevents them from being in ketosis. And the reasons for that are thought to be around their high intake of omega-3 oils in their diet, and also as an adaptation to cold. Not because ketogenesis is in and of itself negative. It isn't, but that's probably also for another day. So basically what I'm saying is evolution is real, and we know that genes will optimize the physiology of a species according to how it does behave. So now, knowing that, all we need to know is how did humans behave in terms of their nutrition for the longest time. That's where we go to the stable nitrogen isotope testing from the collagen of long bones of human remains found all over the planet. Anything over about 11,000, 12,000 years old, pre-agrarian revolution, they all come back the same, except for one example in one paper of a small group of Indians who lived in the Andes at about 15,000 years ago, who were largely plant-based at that time. They were early adopters before the great revolution of humanity. Were they healthy? No. There was also clear signs of disease in those bodies, all right? Every other human remain study anywhere else in the world over about 11 or 12,000 years of age, they all come back and say 80% meat and fat was the diet of this individual, plus or minus 5%. The other 20, 30% was like fibrous matter, roots, not like tubers we have today that we've selectively bred to be more starchy and more palatable and all of that and less toxic. We're talking toxic, horrible, fibrous, rooty things that had to be boiled in clay pots for days on end to soften them enough even so you could chew them up and swallow them. And then there was a small amount of bacteria in the human colon that could break down a small amount of that fiber and produce some short-chain fatty acids. It was a subsistence thing. When the hunt was unsuccessful, or the scavenge was unsuccessful, or whatever humans were doing. So that is the answer. That is what humans definitely did eat for the best part of the last 350,000 years. That's a lot of generations. Before we were human, in species not quite human, but nearly so, that's more like at least 2.5 million, probably more like 4 million years we've been eating meat and fat. Long time. So that's what the species appropriate, species specific diet is.
Okay.
That's why I say that.
What you're trying to say, let me rephrase it. So
Please. Yeah.
See if I understood. What I'm understanding is that you call this the species appropriate,
Appropriate.
Species specific diet.
Yeah.
Because we can eat other things, we can take advantage and take nutrients from other things, but they don't. The other things won't make us thrive.
Correct.
The only thing that would make us thrive is meat. Am I right?
Meat and associated fat. Yes.
Okay. So, as meat is the human diet, this means that introducing I would like to say plants, because that's a case, but I'm going to talk here about carbohydrates, because I want us to speak about plants above 20 grams of carbohydrates, specifically because of the activation of the Randall cycle.
Sure.
I would like you, if you are willing to, could you explain us really quick?
Yeah.
They have an explanation in my channel about the Randall cycle.
Sure.
But if you can tell us, please.
Yeah. Okay. Basically, at its most parsimonious, at its most simple way of describing it, the Randall cycle is an inertia issue. Our mitochondria are oxidizing substrates to produce the ATP that we need for the potential chemical energy I was talking about earlier. Those substrates are largely either fats or carbohydrates. If the mitochondria are burning fats and fats are still available, then the mitochondria prefer to keep doing what they have been doing. They prefer not to change gears. They prefer to keep oxidizing or burning fats. Let's not say burning, because we're not burning anything. It's oxidizing. Different thing. If the mitochondria are oxidizing carbohydrate and carbohydrate is still available, then the mitochondria will prefer to continue doing what they are doing, not change gear. They will prefer to continue to oxidize carbohydrate. Ostensibly, carbohydrate downregulates fat, and fat downregulates carbohydrate. There is this cross inhibition. The analogy I use is two fat men trying to get through a revolving door at once. Oof, the whole thing jams up. That's what's happening if you mix your diet, fats and carbohydrates. So if you have an equal amount of carbohydrate and fat in your diet, you're fine so long as your energy expenditure during the day is equal to or more than the intake of the mass of food in that mixed form. That'll be fine. As soon as there's more energy than you need, Randall cycle kicks in, everything gets locked down, you become inflamed, and inflammation is the absolute underpinning and root cause of heart disease, type 2 diabetes, obesiogenesis, most forms of dementia, and most forms of cancer. All the big killers. They're all inflammatory diseases. And Randall cycle activation, which will happen anytime you consume a meal which is mixed in carbohydrates and fats, every time, there will be a period of inflammation as a result of that. You go and do the math on that for yourself. Is it a good idea to do that to your body? No, not at all. So you need to remove either fat or carbohydrate basically almost entirely from your diet. One of those diets will give you everything you need to thrive and survive as a human being, i.e. the diet which is rich in fat and protein, the animal-based diet. And one of those diets, the plant-based diet with very little animal fat and very little animal protein, but plant protein and carbohydrates, that diet is the one that will kill you quicker than you would die otherwise. There's no two ways about it. It's destitute. If someone comes to me and says, I'm a vegan and I'm not going to stop being a vegan, what do you suggest to me? I suggest several things. Number one, don't ask me any more questions because I can't help you. Number two, if I was going to say anything more, I would say to you, there are at least 12 or 13 daily supplements that you need to take as a vegan to prevent yourself from catastrophically failing in your health in the next 2 to 5 years. 13 or more. Because that diet is destitute. So the choice is easy. Comes back to, how did we evolve? What's our niche? Well, it's obligate hyper-carnivore. That's how you should eat.
Okay, and I have a last question that is not in the I don't include it, but it came into my mind.
Oh, good,
now.
good. I like it when you try and catch me out. Go on in.
Thank you. I have been having this doubt since years now. We have a lot of cases that came into a carnivore diet, but they don't. They cannot lower their glucose in a red meat diet, but they can do it pork or poultry. Why?
There are a number of reasons why a person who eats a carnivore diet might experience higher blood glucose than what they might expect or want. The most common cause is that the person is eating too much protein for their needs. And when you do that, your body will transmute that protein into glucose. There's an issue there probably. Secondly, if they're using something like the HbA1c test to gauge their average blood glucose over the last X number of months, that fails to understand that a person eating a carnivore diet tends to have red blood cells that live longer. So it gives you a falsely high reading, basically. So there's that too. Thirdly, if they're using a CGM, so it definitely is that their average fasting blood glucose is higher than you'd think, even like 100, 110. There's no evidence anywhere in the literature that running your blood glucose at 110 all the time is problematic, so long as it doesn't get much over about 120, 130 or much below 80. So you've got this very narrow range that it stays within. There is no evidence that is problematic for your health at all. None. When they say like 5.6 is the diabetic diagnosis, that assumes that 5.6 is the average of a blood glucose line that goes way up and way down multiple times a day. Up here, where the high spikes are, that's where the damage is done, not down here at 110. So that's fine.
Right. Okay.
If it gets up to 130, we might have a problem. Maybe.
And maybe it's easier to overeat protein in red meat than in other meats.
Depends. I think it's pretty individual, really.
Yeah. Okay. Well, yeah.
Look, work out how much protein you probably need. So the average person, it's going to be 2 grams of protein per kilo of ideal body weight. Not your actual weight, ideal weight, right? So how would you work that out? Take your height in meters. So in your case, 1.53, something like that. So you take 1.53 meters and multiply that by itself. All right. So to grab a calculator, we can actually do this just for a bit of fun. Here's the calculator. Let's say it's 1.53 times 1.53 equals 2.3409. You now multiply that number by the ideal body mass index, which assumes a lot of things, by the way. It assumes that you're of European stock. not
Okay.
Asian or African, because it will throw it off otherwise. It assumes that you are not a hugely muscled hypertrophy athlete or anything like that. It assumes you have a normal body on a normal European frame. But anyway, we take that number, which is 22.5. That's what we multiply that 2.3409 by 22.5. That gives us 52.67 kilos is what you should ideally weigh.
52?
Yeah, 0.67.
I'm near.
Okay, so you're pretty close to ideal, right? Now, how much protein do you need a day times that number, the 52, your ideal mass in kilograms, multiply that by 2 grams per kilo. That gives you 105 grams a day of protein. And the way to work out how much meat you need to eat for that is you multiply that number by 4, because meat is mostly water. And that number works out to about 421 grams of steak. As in, that's what it weighed when it was raw. Doesn't mean you have to eat it raw. You can cook it, but yeah.
I'm overeating. I eat like 70 or 50.
Well, be careful with that assumption, because the numbers I just gave you were for the average person.
Oh, okay.
A bell-shaped curve has that. It has variation around it. I gave you the number that's smack in the middle for what someone needs. For you to say you're overeating, I would need to see something else happening. Are you gaining fat? Or are you weight stable?
No. I'm gaining fat, but because I ate carbohydrates. Now
yeah, okay. That throws the whole thing off then. Yeah. But let's say you weren't doing that. If you were eating more protein than I've just said, but you are weight stable, body composition stable, you're not getting fatter, nothing's happening in that regard, then it doesn't need to be fixed.
Okay.
Don't fix things that aren't broken, is what I'm saying. Yeah.
Yeah. No. I'm eating like 750 grams of meat.
Okay.
Are they more
Does
or
that
less?
include the weight of the fat as well, though?
Yeah. That includes all the steak.
Yeah. Okay. So you would have to actually estimate how much of that was fat, or cut it off and weigh it without the fat, and then still eat the fat anyway.
Oh no. I think that with fat, I would be in, I don't know, probably a kilo, because I don't know, because it's grounded meat mostly.
Yeah.
So it's a little bit of
in your case, there's no reason to worry about how much you're eating, because there's no evidence that you are overeating.
No. I actually was going to tell you that I could be overeating, but the last time I got 3 days into meat and water, just meat and water, and I ate like a kilo a day, and I got thinner and thinner every day. That's no way I was overeating.
Well, I mean, there's this thing that we call priming, where for a couple of weeks at a time, you will vastly, hugely overeat on purpose. And what it does is it tells your body that it's a time of plenty, nothing to worry about, and you can normalize all your hormones and everything's ideal. And your basal metabolic rate goes up as well. So it may well be that you're just priming as and when your body's telling you you should. So again, if it's not broken, it's not worth fixing. Don't even try.
Yeah, I agree. I'm asking these things because of the protein. I was really interested because I have a lot of people that tell me that the protein actually spike blood glucose.
It can do. Yeah, it can. It has that capacity. Yeah.
Okay. Yeah. So I was curious about it, and I also had one case, because I told these people, I told these 2 people that meat could spike glucose in blood, and there was one woman that came with lupus, and she started meat and water, and she got really bad. She got almost ketoacidosis, but she didn't start feeling wrong. She just got her ketones in blood really high, and she got scared. Is that possible, or?
Well, high blood ketones can be problematic at non-controlled diabetic levels, but not in nutritional ketosis. They're not going to get high enough.
Yeah, that's what I told her. She got scared.
No, I'm not going to sneeze. All good.
Bless you. Anyway.
Beautiful. All right. Good. Okay. My pleasure. Yep.
That was my questions. Thank you so much for being here, and it was a real pleasure talking with you. And seeing
Likewise.
you finally smile.
Yeah.
It was really nice. Thank you so much for being here,
My
Bart.
pleasure. All right.
I'm gonna stop now. Muchas gracias a todos por estar aquí, chicos. Aviéntense la entrevista, lean los subtítulos, aviéntensela 2 o 3 veces, van a entender muchas cosas. Muchas gracias por haber estado aquí. Dejen su like, compartan este video con sus amigos y si no les está gustando y les molesta que traiga científicos a hablar de ciencia, compartan este video con sus enemigos para que les arruinen el día.
De nada.
Y muchas gracias. Recuerden que todo es mental, pero la mente es bioquímica.